Section 4.3 homework point 15. The following data represent the time between eruptions and the length of eruption for 8 randomly selected geyser eruptions. We're going to complete parts A through C below. Now, the first part says what type of relation appears to exist between time between eruptions and the length of eruptions. So we're going to click here to look at the scatter plot. If you take a look at this data, you can see it's all kind of close together. And then going from left to right, it is going up in a positive direction. And it looks like you can fit a nice line in between all of those points. So what we're going to say is it's going to be a linear and a positive situation, which is a positive association. So let's check our answer, and there is our result. Now it says, does the residual plot confirm that the relation between time between eruptions and the length of eruption is linear? So let's click on this plot here. So if you take a look, you have all these points here and then all these points here, which is a residual plot. If it was going like up and then down a little bit more here, this would be a discernible pattern, but it's not a discernible pattern. Therefore, we're going to say the following. It says that the plot, this is going to be yes, it is linear, and the plot of the residuals show no discernible pattern, so a linear model is appropriate. Okay, the next question says the coefficient of determination is found to be 93.8%. We want to provide an interpretation of this value. So before we do that, let's just take a look at our information here. It says the coefficient of determination measures the percentage of a total variation in the response variable that is explained by the least squares regression line. So again, keep in mind we're talking about the response variable here. Now it says a large value, which is close to 1 or 100% of the coefficient determination, implies that the unexplained variation is a small portion of the total variation. Conversely, a large value of the coefficient of determination implies that the explained variation is a large portion of the total variation. We're going to use this information to draw a conclusion regarding the relationship between the given value of the coefficient of determination and the variation in the least squares regression equation. Remember that this coefficient is based on the variation of the response variable and not the explanatory variable. Remember that the response variable is the y, so that means we're looking at the length of the eruption. And note that the explanatory variable is the time, right? And again, the coefficient determination measures it in the response variable. So let's go back to our question. We're going to say the least squares regression line is going to explain this amount of percent. So we're going to put in 93.8% of the variation in, again, which one is the response variable? Well, the response variable is the length of eruption. And check our answer, and there is our result.